Welcome, curious minds, to another deep dive. Today, we're taking a bit of a shortcut to getting really well informed about something fundamental to our digital world, Linux system administration. I've got some interesting sources today. We're drawing insights from XK0-005 exam practice and Linux system administration. Now, even if you're not prepping for that specific exam, our real mission here is to pull out the practical, sometimes kind of surprising, nuggets of knowledge, the stuff that's vital for anyone who interacts with Linux systems day to day.
Indeed. Yeah, we're going to look at some.
Okay, great. Let's unpack this then and jump right into our first real-world scenario. So imagine this. You're an administrator, and maybe system stability is becoming an issue. You figure out you need to limit the maximum number of open file descriptors for one specific user. It'll stop a single process from maybe hogging everything. The key is you've got to make this limit persistent. So where do you actually make that change? Which file?
Right. Yeah, that's a good one because you want user-specific and persistent. And for that, the place you need to go is at settersecuritylimits.com.
Limits.com. Okay.
What's really interesting here is how this specific file ties into PAM, the pluggable authentication modules. It's literally designed for setting these kinds of user resource limits, like no file, which is the one for file descriptors.
So PAM helps enforce it based on that file. Why is that no file limit so important for stability, though? What happens if it's not set right?
Well, if a user's process just starts opening files without any check, I mean, tons and tons of them, it can genuinely exhaust system resources. You run out of available file handles system-wide. That can really degrade performance for everyone, cause other services to fail, or, yeah, even crash the entire system.
All right, so limits.com gives you that precise control per user, which you don't get from, say, etcetl DLL.com.
Exactly. sysshell.conf is more about broad kernel parameter system-wide stuff. It's not for targeting individual users like this. And other files mentioned sometimes, like etclogin.defs or etc. stab, they're just, well, they're unrelated to this specific kind of resource limit. Limits.conf is the tool for this job.
Got it. Precision matters there.
Oh.
Okay, let's talk about another classic head-scratcher. You got a script. Maybe it's meant to back up user home directories. Seems fine. You've checked permissions. It's got to execute. It's sitting in this locale bin, a standard place. But when Cron tries to run it, nothing. Silence. It just doesn't execute. What's like the very next thing you should probably check?
The silent cron job failure. Yes. This is super common. You've checked all the obvious things, permissions, path. So the most likely culprit and often overlooked is the script's shebang line.
The shebang, that hashtag thing at the top. Why is that so critical, especially when cron is involved?
Well, the shebang, like hashtag bin bash or hashtag.es or bin python, tells the system which interpreter program it needs to use to actually run the script's commands. Now, cron jobs, they run in this really, really minimal environment, very stripped down compared to your normal interactive shell. So if that interpreter isn't explicitly defined by a correct shebang right at the top of the script, cron might just not know how to execute it. Even with the execute bit set, it just fails, often silently.
Right. So it's not enough for the file to be executable. The system needs to know how to execute it via that shebang, especially in cron's limited world.
Precisely. It's a fundamental piece of shell scripting, but easy to forget when you're automating things. Trying things like trod 777 is just, well, it's bad practice and a security risk and unlikely to fix this particular problem anyway. And restarting system journaled or messing with except sudoers, totally unrelated to why a basic script wouldn't execute via cron. Check the shebang first.
Okay, good advice. Now, speaking of things that can trip you up, system. Here's one I think many of us have run into. An admin updates a config file for some service managed by system, maybe a web server config. They dutifully restart the service system, it's like restart my service, but the changes just don't take effect. The old behavior persists. What's the essential action to make system actually recognize that new configuration file?
This is such a classic systemed interaction, isn't it? The key here isn't just restarting the service. You need to run system-tiled daemon reload first.
Daemon reload. Okay, why? Why isn't restarting the service itself enough? It feels like it should be.
I know, it does feel that way. But the thing is, systemed itself kind of keeps its own internal list or cache of all the unit files, those service configuration files. It reads them once and keeps them in memory. When you just edit the file on the disk, system DAC. Well, it doesn't know you did that. It's still working off its old cached information.
Ah, okay.
So simply restarting the service tells the service to stop and start, but it uses the configuration that system currently knows about, which is the old one. System tag daemon reload explicitly tells the main system process, hey, go reread your configuration files from the disk because something might have changed. After you do the daemon reload, then when you restart the service, it will use the new configuration that system just loaded.
Gotcha. So it's a two-step: reload the manager's brain, then restart the worker.
Exactly. It highlights that system isn't just starting things, it's actively managing them based on its loaded configuration state. Other commands like system-tac reload service name are different too. They usually tell the service itself to reload its own internal config, not system's understanding of the service unit file.
Makes sense. That distinction is crucial. All right, let's pivot a bit towards security. Another common scenario. A user calls, they can't SSH into a server using their key. Key-based authentication is failing. You check, and yep, their public key is definitely present in the unauthorized keys file on the server. The key is there, but login still fails. What's the most likely gremlin causing this headache?
Right, key is there, still no login. This almost always screams permissions issue, but a specific kind. The most likely cause is that the authorized keys file itself, or maybe even the containing .sh directory, has incorrect ownership or permissions. Specifically, it might be owned by root instead of the actual user.
Owned by root, that seems backwards. If the key's content is correct, why does the file ownership matter so much that SSH just refuses?
It's a core security principle for SSH. Think about it. The authorized keys file basically says anyone presenting the matching private key is allowed in as this user. Okay. If that file could be modified by someone other than the user, like root, or if permissions are too wide open, it creates a massive security hole. Someone could potentially add their own key to your file. So the SSH daemon is deliberately strict. It checks. Is the .sh directory owned by the user and only writable by the user? Is the authorized keys file owned by the user and ideally only readable by the user? Okay. If those conditions aren't met, like if root owns the file, SSH basically says, I can't trust this file, and ignores it completely for security reasons. Authentication fails.
So it's a sanity check, a safeguard. The user must own and control their own authentication credentials file.
Exactly. Permissions should be strict too. Usually 700 read-write execute only for the owner on the .yashu directory, and 600 read-write only for the owner on authorized keys. Other possibilities, like the SSH daemon running on a weird port like 443, are less likely if basic SSH connectivity works otherwise, and Linux in permissive mode would typically allow things, not block them. So ownership and permissions are the prime suspects here.
Good point. Always check ownership and permissions first for SSH keys. Okay, final scenario. Let's talk troubleshooting and logs. An admin is debugging a service. It's managed by system, naturally, and it's failing to start. Just won't come up cleanly. They need to see the logs, but not all the system logs, just the recent messages specific to that failing service. What's the command for that?
Digging into why a service failed. Yeah, you need targeted info. The command you want there is journal LQ service name. The UQ flag stands for unit.
Journal LQ. What makes that command so effective compared to, say, just tailing var log messages or using journal LQ?
Well, journal up service name filters the entire system journal specifically for messages logged by that particular service unit. It shows you, in chronological order, news last by default, exactly what that service tried to do, any errors it reported during startup, or any runtime messages. It's incredibly precise.
So it cuts through the noise.
Exactly. Journal shows you all recent system logs, plus maybe some diagnostic info, which can be overwhelming. System total status service name gives you a snapshot and maybe the last few log lines, but often not enough detail for deep debugging. And tail har log messages. Well, on many modern systems using journaled, services might not even log to varlog messages anymore. Their output goes straight into the journal. So journal tell is really the purpose-built tool for getting the relevant system service logs quickly and efficiently. It's indispensable.
Okay, that makes a lot of sense.
Understanding the logic of the system so you can manage it effectively, keep it stable, and secure it properly.
Absolutely. It's like knowing the grammar of the system, not just the vocabulary. These details: limits.com, shebang, daemon reload, ownership, journal error, HELS genie all. They're the punctuation and syntax that make everything work correctly. They're not just isolated facts, they're pieces of that bigger puzzle, ensuring systems are robust, secure, and hopefully run smoothly. It really does make you wonder, doesn't it? What other seemingly minor commands or config settings are out there, holding surprising power? What's the next hidden rule you might stumble upon that suddenly explains weird behavior or saves you hours of painful troubleshooting? Keep exploring, keep asking those questions, and definitely join us next time for another deep dive into the fascinating world of knowledge.